Hi, my name is Ewan Slater. My talk is entitled Free the Functions, and it's about open source serverless and the FN project. Over the next 20 minutes, I'm going to talk about serverless, what it is, why it matters, why you should choose your serverless platform carefully, and the FN project. Now, my role at Oracle is I'm a cloud architect, which means that I work with Oracle customers and partners, helping them to design, build, deploy, and run applications on the cloud. But what I really do, and what I've done all the way since the start of my career as a research scientist, is I solve problems. And solving problems generally boils down to a few things. One of the keys is to simplify the problem. Yeah? If you can make the problem as simple as possible, then it's easier to solve. So you break it down into chunks. You restrict the scope, so you make sure that you're focusing on the thing that really matters. And something else that's really important is choosing the right abstraction. So, for example, if you are looking at geometry and you are considering, the surface of spheres, for instance, if you choose the abstraction of spherical polar coordinates, the maths will be much easier and your problem will be much simpler than if you try to persist with Cartesian coordinates. And abstraction brings me to serverless. So, what is serverless? Well, the CNCF definition is this, and I've put some of the words in bold for emphasis, but serverless computing refers to the concept of building and running applications that do not require server management. It describes a finer-grained deployment model where applications bundled as one or more functions are uploaded to a platform and then executed, scaled, and built in response to the exact demand needed at the moment. Things are going to run when they're needed. They're not going to be running perpetually waiting for stuff to happen. So what serverless is an abstraction. We've abstracted away the infrastructure and the operations we associate with that. And if we build an application and run it on top of this abstracted infrastructure, we can say that we have a serverless architecture. And as developers, then we can concentrate on delivering what the business want as functions, or using functions as a service, because that's the compute component of serverless. That's where our business logic's going to execute. So when we're in FAS, what we're doing is we're writing small functions. Because they're small, they should be easy to write, they should be easy to get right. They should do one thing well. They should be easy to understand. They should be easy to maintain. And we're going to run them on top of this serverless platform or abstracted infrastructure. Now, the University of Berkeley did a report on serverless computing in March. It's well worth looking at. I've called out a few points here. But they're talking about people being attracted to serverless functions, serverless computing, and especially to functions, which they describe as a new compute abstraction that promises to become the future of cloud computing, which may be a bit hypey, but I think what they're getting at is that in many cases what we've been doing so far with cloud is taking traditional applications and moving them to the cloud, or creating applications that look like them on the cloud. So what we've really done to date is rehosting. With serverless, we actually start to move to the point where we develop applications for the cloud rather than just ones we run on it. And what do people see? Well, customers see an increase in programming productivity and also cost savings because you're only consuming resources when you need them. From a developer's point of view, we also avoid this scenario where the business asks us to do something, and before we can do the thing that they think we should be doing, there's a bunch of stuff that we have to do beforehand, which frustrates them. So serverless takes us away from that because that is abstracted away. So, the upsides of serverless. It should make development easier. It should improve developer productivity, which should increase our agility as developers. That should help make the business more agile. And it should also reduce the cost to develop software and to operate it. Now, if there are upsides, there must be downsides. The number one that I see at the moment is shiny. Serverless is cool, it's hot, so people will use it everywhere, and they are bound to use it in places where it's not appropriate, and then they'll get upset and blame serverless. The other issue is lock-in. You can't necessarily take something that you've written for one serverless platform and run it on another. You may also find that certain platforms restrict your choice in terms of languages that you can write your programs in terms of where you can write your programs, and they might be quite opinionated and inflexible about how you abstract your functions and model them. So in a sense, when you choose a serverless platform, you're almost choosing a cage. It might be a gilded cage, it might be a very, very nice cage, but before that door shuts and locks, I think you need to be sure that there is enough freedom in that cage to keep you happy. Now, I talk to people and I work with people for whom one or some or all of these freedoms matter. They want to be free to choose what language they write their functions in. They want to be free to choose where those functions run. They want to decide how they package their applications up. They don't want to be dependent on a single vendor. They may, as individuals or as organizations, have bitter experience of being dependent on a single vendor and having trouble when that relationship goes bad. They may want to be able to move their functions from one cloud to an on-premises environment to a different cloud, or even run in a decentralized model across multiple clouds simultaneously. They may also have privacy concerns. They don't necessarily trust all of the public cloud providers. And the ultimate freedom that you get, or the ultimate freedom that some of them want, is the ability, if they decide the platform direction is going in a way they don't like, is the ability to fork off and even create their own serverless platform. So what they really want to do is to free the functions. And the way that we're going to free the functions is by moving to open source serverless. Now, there are a number of open source serverless platforms out there. There's OpenWhisk, for example. There's OpenFaz. I'm going to talk about FN because it's the one that I work on. That isn't my day job, by the way. So, FN Project is an open source serverless compute platform. You can deploy it to any cloud or on-premises or on your laptop. And we model the functions as containers. There's a large number of people working on it. I'm a contributor. We have native support for cloud events. It's backed by Oracle, but independently governed with representation at CNCF. And we have a language-based workflow mechanism called Flow. Now, what happens with FN is you take a function and its dependencies and you bake them into a Docker image, which gives you a single-purpose, self-contained package for your function. The function inside should be stateless. Any state required needs to be written out to an external storage or database. Because these are ephemeral, they will be run on demand, they will exist while they're executing, and then they will go away. And so what your FN function looks like is a small chunk of code. It's been wrapped into a container image. It takes its input from HTTP stream, which is basically HTTP over Unix sockets, and any environment variables that are set for that container. Writes back on HTTP stream, and it logs to syslog. So here is hello world in Ruby for FN. So the first thing we do is require the FDK. That's the function development kit. I'll talk more about that in a sec. And then we have our function here. It takes two arguments, context and input. Context is kind of metadata about the invocation. The input's actually the payload. In this case, we check and see if we've been given a name and say hello name if we have, and if not, we say hello world. And then the FDK's handle method is called to execute that function. Now, you can get that boilerplate code from the CLI, and you do fn init ---- runtime, Ruby in this case, there are others, and you give it a function name. Then you deploy the function into an app, which is really kind of like a namespace for functions. And then you can invoke it either using the command line or this ultra-memorable and friendly URL. What actually happens with the deploy is we do a multi-stage build of the container. When we push it to a registry, you can use Docker Hub if you like, and then we create and update function endpoints, and the server will lazy load the images when required. FDKs, function development kits, they make it much easier to write the functions because, as in the example, what you do is include the package or library or gem or whatever your language calls that kind of thing. You write your function against that interface, and the FDK is in charge of providing the input data to the function and writing out any output and errors. At the moment, we have FDKs as part of the project for Python, Ruby, Java, Node, and Go. .NET Core was recently added. And for my sins, I maintain the Ruby FDK. The way the FDK works, it opens a socket inside the function container, and the FN server connects to that socket. The FDK then parses the input from HTTP stream and executes the function, giving it the input and the context, and sends back the output and logs any errors. If you don't have an FDK for your language, that's not a problem. Because it's based on Docker, you've got a couple of options, 3 actually. So the easiest one is bring your own Docker file, and FN will build a function on that Docker file. Or you can bring your own image, and FN will let you build a function based on that image. The other thing you can do is use something called hot wrap. So if you have a program that runs from the command line, you can put that into a Docker file, and then you include the hot wrap binary as part of the build process, and effectively that will take the input from HTTP stream and pass it to your program on standard in, take what your program returns on standard out, and send it back on HTTP stream. Oops. So from hot wrap, we go to hot functions. So I said our functions were ephemeral. They actually run at least once. Then once they've run, there's a short wait before they terminate. By default, it's 30 seconds, but that's configurable. And if you get another invocation before the function's timed out, then we'll reuse that container rather than spinning up another one. So the function containers are potentially reusable, and the FDK needs to handle multiple invocations as well. It also is another good reason to make sure your functions are stateless, because if there is a subsequent invocation, you don't want something hanging around from a previous run that's going to cause problems. As I said before, FN deploy creates a default endpoint with a non-friendly URL that's used by the CLI, and you get one of those per function deployment. We also have the concept of triggers. So you can use triggers to have more memorable or meaningful URLs for humans. You can have multiple of these, so you might have different URLs for different audiences. And you can either create them on the fly using the CLI, or in the func.yaml, which is the descriptor for the function. The FN server is the API gateway, so it manages the apps and functions, and as I said, the app is basically a namespace for a bunch of functions, and it handles the function invocations. It itself runs as a container, and it hosts the function containers using Docker in Docker. That means that if something goes wrong, we've limited the blast radius, we don't affect the outer VM. It also means that we're not so dependent on what the Docker version is in the host environment, because we can have a different Docker version on the inside. And it reduces the chance of container name collisions. In production, which you'd typically run this on top of Kubernetes, but you have a load balancer, then you'd have a group of FN server instances, you point into a container registry, you'd also have an object store and database for metadata. And the request process goes something like this. A request comes in, You route it to the FN server, and then it checks and says, have I already got one that's running that'll do? If I have, I'll send the request to that. If not, I'll spin it up. If I haven't already got it, I'll have to pull it from the repository. And then I'll send the business data back to the caller and put any information for logs, etc., into the object store. Now, I said our functions were small, so they're unlikely to be able to do a significant business operation in one function, so we need a way to orchestrate them to work together to do the business meaningful tasks. And in FN, that's something called flow. So it's a promises-based orchestration. So you don't have to learn a new dialect of YAML or XML or anything like that. And what it gives you is a way of composing your functions together. It's flexible. You can run the functions in series. They can run in parallel. They can run synchronously. They can run asynchronously. And your flow would be written in code, Java, for example. It itself is written as a function and deployed as a function within an application. So if you wanted to, you could put business logic in here, but I would really suggest not doing it. I think the conductor should conduct and the instrumentalist should play the instruments. So we can, for example, use Flow to implement something like a Saga Pattern, where you've got a business transaction that's spread across multiple services. You can't use something like two-phase commit, so you have a set of local service-level transactions. Each one triggers the next event. And on failure, you would undo a previous transaction rather than roll back. So say apply a credit instead of a debit. So we can potentially have FN act as our travel agent. So in a travel saga, we want to go on holiday. We want a hotel and a car and a flight. So we start by booking the flight. If that fails, we'll just stop. Otherwise, we'll book the hotel. If that fails, we need to cancel the flight as the compensating step. Otherwise, we'll book a car. And if that fails, we need to cancel the hotel and the flight. Otherwise, we're going on holiday. So the code for that would look something like this. So we've got you can't see that on there. We've got a flight future up there. We've got a hotel future. We've got a car future. And then we compose these together. So we start with the flight future, and then we go to the hotel, and then the car. And if everything works, we get here, it's a success email. Otherwise, we're going to exceptionally compose, and we're going to first retry and then cancel each of those functions in order. So at the end, we'll either be going on holiday or everything will be cancelled. At the moment, Flow has language support for Java and Python and Node. Go is in the works, and Ruby is on my to-do list. So, in summary, serverless is a way of using abstraction to simplify what we do. It should enhance developer productivity. It should lower our costs. And in many ways, it's liable to become the dominant paradigm for developing new applications. But you should choose your platform with care, because it is, to some extent, a gilded cage. And the FN project is an open source serverless platform. It's portable, you can run it anywhere, it's language agnostic, it has multiple FDKs built in. Feedback and contributions are welcome. If you want to learn more, fnproject.io. We've got a Slack workspace and a friendly community there. You can follow us on Twitter or check us out and even contribute on GitHub. Thank you very much. My name's Ewan Slater, and if you want to get in touch with me, Twitter's probably the easiest way.
There are no questions from the audience, but I have one myself. How do you control the number of Docker containers a FN server can spin up?
So within the server, you can configure, are you thinking about how much memory and how much resources it's going to consume? Yes, you can configure that for the Docker container that is the FN server.
Okay, thank you. So thanks again